Hello, hello. You are my hero, says Deagle. Hello, Deagle. How are you doing? Alright, today we continue working on cast language. Speaking of heroes. Speaking of heroes, what? Yesterday You're staying awake for your Hero Academia? Episode 8? Hero Academia? Is that like the TV series? Is that an anime? Never watched it. 8 seasons. Is it a good one? I'll keep that in mind. Maybe next time I think about what to watch, we'll try that. All right. I was making the thing yesterday, which is called the sum types. Right? We have anonymous sum types right now. And off stream, I added the ability to specify the types in the type annotations. And today, I think what I need is to do the whatever is any. Yeah, sure, we can rename this. Oh, wait, this element cannot be renamed. Why not? Let's fix this first, I guess. But later, I want to do pattern matching. But let's fix the renaming. Making rename work for some types, and then we will do pattern matching. So whatever is any, yes. How do I rename? Because like, yeah, I can also not go to the definition. I should be able to go to the definition here, but I'm not. And I cannot rename things. So let's fix that. I can rename and go to definition work for some types like that. Hello, penguin operator. So why would I not be able to do that? If we have, like, because this is an expression, right, of type. It's probably just the LSP stuff that I need to change. LSP hover probably is the only thing I need to change. So when I'm hovering specifically, yeah, when I'm hovering specifically, let's get rid of these warnings too. If I hover specifically, yeah, I do have like a dedicated thing for hovering a tuple. And in that case, it would be an expression or type expression of a variant. So we have expression variant. We have label. We have value. Right? Yeah. That's what I need to do. This also means that I need to keep the span here. Label span. So I will return here some span is label span. Definition mode is defined not here. Label definition label. Unbound value label. Is because I need a label span here. All right. Label span is span. Print. Label span. Ignore for printing. Interpreter common. We will ignore the label here. Compiler init. If we have a expression variant, label span, then we should have this. I guess I can ignore it here. It's for defining the determining the type. In core syntax, if I have expression variant, I need to say that label span is label AST span. And now in LSP common, expression variant, label span can be ignored. Okay. So what did I do? It should allow me to get to the definition of this thing, right? So if I do sum, it doesn't, that's, oh wait, no, that's right. Because in this case, the sum is not necessarily the same sum, you know? Yeah. But if I go to the definition over here, then this will get me to this place. If I go to whatever, then I go to this whatever. If I go to none, then I go to this none. All right, nice. So go to definition works now. What about renaming none, none2? It seems like it works, and it renames it in all of the places. If sum renames sum 1 to 3, that works. It didn't rename this one because that's from a different type. And if we rename whatever to any, then it renames properly. All right, nice. But I cannot rename right now over here in the type expressions. Let me fix that too. So I need to also say LSP hover. That's expression variant, but into a type expression variant, right? Rename be match compiled shape with anything than none. It is type expression variant. What is variance here? This is label and type expression option. So that's wrong now. Because type expression variant, similar to type expression tuple, should have a tuple type expression tuple field of. It's field span and field label. Yeah, I need this tuple field of. Kind of thing. Which is technically, we just say that it is field, we just say label, and then label span, like this. That's what I do. Print. When I am printing, label span, interpreter common, here, variance, label span, core syntax. So for a variant over here, I need to also give it the label span, label and label span. And I just say that let label span be that. Interpreter common. Nope. Where do I have the problem currently? Now on the LSP common variants, label span, and then I want in LSP hover. Yeah, so I have the variants here, and now we say variants. This is the list. We say list find find map, I guess. Right? Find map function variant, which is label span, label, and value. And then we say that if label span span contains hover span, then I'm going to return this thing, otherwise we'll return none. And I will return span is label span, and the definition mode is defined here, because that's where the type is being defined, right? Binding definition. No, not binding definition. Label definition. Label. I think that's all that I need to do. Let's check. Restart language server. Variant types. So now we can go to the definition here. What if I try to find... Yeah, see, I try to find all the references of this thing, and I can see it. Okay, so if I try to rename here, that works. If I try to rename here, then that also works. Okay, nice. That's nice. Okay. Renaming and go to labels of variants. Call them variants and some types. So that's done. All right, now we go to pattern matching. So pattern matching technically is already here, because when I say let A, that's already a pattern. But when we say pattern matching, it's when we have the conditions, right? So we try to let's try to have like a function. Let's try to have a function print variant, right? Print variant. We have the value, and then I want to like match value with all of these different options, right? I want to match it with if it is sum, then we say sum. If we say none, then it is none. And if it is any, then it is any, right? Something like this. And we want to, I don't know, let's use std prelude here. And we'll do print. Let's call this thing variant name, print variant name of A, right? And then print after every like assignment here. Something like this. Okay, so all right, now I don't have the syntax. Is that the syntax that I want? I think that's an okay syntax. Not sure about this though. The arrow. Do I use the fat arrow like Rust? I feel like that's what I do. Syntax. So like technically, we split this syntax. Oh wait, actually, do I split this syntax? Biters, code bugs, attack the code. Hello, Amsoft. Welcome. We do have some bugs here for sure. But it's going pretty well so far anyway. Let me know if you want me to explain what I'm doing more or show the language a little bit. But currently I am trying to implement pattern matching. This is what it's supposed to look like. I'm going to implement the new syntax here. Match. I think one of the things that I'm missing is the groups which are repeated. Right? Maybe I do that first. That would be nice. You don't know nothing about Rust? You're more in C++? Well, it doesn't matter because I don't use Rust right now. I'm currently using OCaml to write my own language, and I'm working on my language, right, which is neither. But C++, you have this thing. If we talk about C++, then there is this thing called std variant, right? So that's what I'm doing right now then, std variant. C++ std variant, this thing. This is allowing you to have a type-safe union, right? Because I want to have a type-safe language. so it's harder to do bugs than like in C++, where you can have an undefined behavior on every line of code. We don't want that. And then pattern matching in C++ is... How do you pattern match in C++? Visit? Is it visit? So you visit for every other variance, right? These are all the overloads. Yeah, I think that's how you do it. Pattern matching in C++ by using the visitor. You're the first one who uses VS Code instead of Vim and other weird editors. You want me to launch Vim? I can do it right now. I don't care about the editor too much. But VS Code is just working. And the other editors, they break sometimes. I mean, VS Code technically also breaks sometimes, but you know, like I don't care. I don't care. The editor is like irrelevant, you know. And the language that we use is also kind of irrelevant, because all of the languages have very similar semantics, most of them at least. It's just different syntax for the most part. Pattern matching, let's go. Yeah, pattern matching. All right. I'm trying to make the syntax. So I was thinking, what do I so like previously in the previous version, what I was doing is that we had a separate syntax match value, and then over here the branches, and the branches are like done fakely using this existing union syntax, the vertical bar, and over here this is the syntax that is already existing. This normally means function definition, right? Like over here, that's the same syntax, right? You have the pattern, fat arrow into the value. That's like a lambda, right? So we can reuse existing syntax. Or I do something else. What VS Code font is that? I think I have the font command. Yeah, there you go. It's monospace. Hello. So in order to do that, like without hacking using existing syntaxes, I would want to define a syntax core match, right? I would want to define the syntax as match value. Then I open the bracket here. I close the bracket. Will there be other pattern matched types like linked lists? I don't know, maybe. I mean, we right now already pattern match like tuples. Pattern matching already exists, we just don't have the match expression, which is like conditional pattern matching, I guess. Patch value. So what I want here is we want to have like variance B, and then we have a star here, right? Which is all my variance. And then we have pattern. So we have a vertical bar. This vertical bar should be optional though. The first one. Pattern. And then fat arrow. And then body of this variant of this branch. I guess this is called branches, right? So that's what we don't have. Right now we have optional things in ASTs, but we don't have repeated things in ASTs, right? These things. You need inbuilt matching for list though, unless you're going for the nil const route. Not necessarily. I don't need it to be built in because we have macros. We can have a macro. We can have this syntax, like if we do the OCaml syntax of a head, colon, colon, tail, that could automatically be done with a macro so that it matches, you know, it matches cons, you know, head and tail like this. Can automatically be done like that. So it doesn't need to be built in, I don't think so. Well, I mean, if that's how the lists are implemented. Are the lists built in? That's the question, right? Arrays now, not linked lists. Well, I don't have arrays right now, so yeah. We'll see. AST. I'm just wondering how difficult is it? Group. Rule is only none for root. We'll have a group. Group has parts. Group is optional. Parts is a list, so we have a part. Part is either a group or a part. Group. Group is this. So I need to have a new part, which is like... Wait, how do we do optionals? We just don't have it, right? Child. I think it's a child. We either have an AST or a group. But we also potentially should have like a list here. If I want to add quantifiers, I think I will still go without quantifiers. Maybe when we rewrite the language in itself, I will add this properly. I think it's fine. Let's just say that we match value using branches. Like this. The PR that got away. Well, unless you want to implement this. I think since I have the optional quantifiers, you can figure out how to do the lists, maybe. But it's still not super straightforward, I guess. We do the formatting here, so we do like this. And then we say space slash 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 n. And what's the priority of this? Something similar to an if, I guess. So priority of a 4, just like an if. I think I see an issue. I might want to do something literally similar to OCaml with a with keyword. Right? Because if I use the... Yeah, because I have this opening bracket, right? Does this mean me calling a function value with this as an argument? Or does this mean a start of the match? And if I want to match something that match calling function f using arguments, then which of these parentheses opens the match branches? I think having a with keyword is fine. We'll see. Maybe I will change it later. Let's restart language server. No, that doesn't work. Is it because the function has higher priority than the if? So this doesn't work unless I do this in parentheses. Okay, also I forgot the space after match here for the formatter. There we go, so we can format code like this. Do I want this to be possible without these parentheses? Because it seems unnecessary, but this means that the priority of the match should be higher than the priority of the fat arrow. Well, I mean, it should be, yes. And same should be true for this field initialization also. Maybe ifs and matches. Wait, what about the comma? Yeah, if should be more priority than the comma. For sure. I don't know. I just have wrong priorities here. Let's move things around. Over here, if and match. Are just going to be of priority 7.5 then. Let's see. Does that work? This vertical bar is now unexpected. Because now the union is over here. Okay, what should be the priority of a union? Oh, this over here must be any, because we already have the parentheses there. I need to say that this has any priority. And then this works. Okay, nice. Yeah, that's nice. Okay. So now I need to implement this syntax, right? It says that there is no core syntax match. Core syntax match. It's going to be very similar to the CFG if or target dependent, I guess. So let me copy paste this into a match. So now we have the branches. But we also have a value and branches. So this is a value and branches. No, it's unwrap name too. That's it. Okay, so we have value, which is AST, and branches, which is AST. Okay. Branches, now we collect the list using the unions. Okay, and then every one of them is the core function. So it's kind of the same. This is a little bit of copy pasta, which maybe to do reduce copy pasta of this and target dependent. But for now it's fine. We have the branches. That should be not an expression target dependent list. It should be something else. Let's first figure out how I do it in the types, right? So I need to have an expression. I need to have a new expression, which is a match, similar to an if, right? Expression match of expression match. Okay, and now expression match has a value, which is expression, and it has branches, which is expression match branch list, right? Expression match branch has a pattern, which is pattern, and has a body, which is expression. That's all that I need to do, right? Okay, let's do the printing for this expression. Expression match value branches. We do printf fmt we say match, and we do tuple print. Match. We match value with branches. So value is just print expression, and branches is going to be list print. Print match, print expression match branches. Okay. And print expression match branch is function fmt into pattern and body. It just has this thing which has pattern and body. Pattern is print pattern, and body is print expression. Body. Okay. Interpreter. So when I evaluate, expression match, we have value and branches, right? Okay. So first we evaluate the value. Value is evaluate the value. right? And then and then and then and then we go into branches and we do list find map. We find a specific branch. And then we see. If we didn't find it, then there's going to be an error. Right? But if I did find result, then it is result. This means that pattern matching is not exhaustive here, so we do error span expression data span pattern match non-exhaustive. And over here, when we have a branch, what we do is we try to pattern match this value with this branch's pattern, right? Okay, so pattern match. Pattern match right now is a function which always succeeds, right? But we should do it so that it does not succeed, right? So this should match the pattern optionally, technically, right? But since we want error resilience, should this return like always the matched things? But sometimes it will also return, and it will also return, you know, matched, a boolean, like this. That's what we want. So for example, when I'm trying to pattern match with a placeholder, I know that this matches everything, so matched is true, right? If we want to pattern match a unit, we kind of just want to assert that the value is unit, but it should always match. Do a colon here. If we have a binding, that also always matches. So the only thing that is optionally matching is actually the variant types, I guess, right? A tuple also should always match. Tuple has different sets of fields. Sure. And then we have the error. I don't know if the error should be treated as something that has matched or not. Probably actually as false. So field matches is pattern match, and field matches... Oh, field matches is whether we matched or not, actually. Yes. Return. Symbol map, empty symbol match. This is matched bool times interpreter matches. Build value. We have the accumulator. Okay, I think, okay, I guess, yeah, because tuple has inner patterns. If the inner pattern doesn't match, then the tuple itself doesn't match, yes. That makes sense. So we have the accumulator of matched. So originally we match, and then we go over the fields, right? So accumulator is matched and accumulator. And over here, a return matched is matched and field matched. And we return this symbol map united. So this is matched is field matched. That's what we want. And now the syntax error, which is impossible to see in a camel. Does this need to be in parentheses? It does. By symbol. Yeah. I need to have this as an argument. Right? I need to say that let matched and matches, I guess, is this. And by symbol is matched. Matches, and then we return also matched. Is that what we want? No. This expression has type matched A times B, but expression has type locals. Oh, because this returns scope locals? Yeah, it doesn't return scope locals, it returns matched boolean times scope locals, right? And then somewhere where I actually use this return, maybe like over here. If tuple has different sets of fields, I should return that matched is false. Okay, now it actually compiled, nice. And over here, if we expected tuple but got something else, then this is also an error, so matched is false. All right. Okay, now we use the pattern matching in multiple different places, right? Over here, when I'm trying to call a function, I'm doing the pattern matching, but we basically should ignore the fact that it matched or not, right? Matched and arg bindings. Matched is arg matched. But I should say something like that if not argument matched, then I should at least throw an error, right? I should say that error span didn't matter match functions argument. Pattern match failed to pattern match function arguments. Technically this should not be impossible because of the type checking, but we always allow errors to happen. New binding. So yeah, it's similarly, if we have a let pattern be value, then we want to do same matched and new binding. So we just say that if not matched, then I just throw an error. And do I not have the span here in assigning? We have expression assignee, right? So we say error span would be assignee data span failed to pattern match. All right. Then when we have unwindable, we do pattern match token pattern. Function matched locals. If not matched, then error and well, the span would be token pattern data span failed to pattern match token unwind token. Okay, and now we go back to actual pattern matching. So now when we go over the branches, the pattern matching is optional, right? So now we actually try to do pattern match of a value with the pattern, which is branch.pattern, right? And then we say let matched and matches be this in. If matched, then I return something. Otherwise, I return none. But what do I return here? This should return a value, right? This should return a value. So I need to say inner state is enter scope state. And we say inner state scope add locals matches. And then I return evaluation using the inner state. I evaluate the branch body. Branch body is an expression, unbound record. Is it because you're stupid, Camel? Branch is expression match branch, right? That's what you want. Nice. Okay, next we need to initialize the type inference for pattern matching over here. If I have expression match value and branches, then let's see, what should we do? So I should just say that we have a result type. Result type is type new not inferred. That is going to be the type of the entire match expression, right? And then we go over the branches. And we go over the branches. And we do something. Yeah, we return the result type here. But we go over the branches and we say that branch pattern type is the same as the value, right? Because we must match. So pattern should inference type expect inferred as span is going to be a branch pattern data span. We infer this as a value type, right? So value type is value data type, right? And then also we need to just assert that each branch's pattern is the same type as the value that we're matching, and each branch's body is the same type as the result type. So all the branches return the same type. Inference type, could infer it as span is branch body data span, and result type. I think that's all that I need to do. Your camel transpiler keeps just getting more to-dos. LSP common. This just should handle the inner ones. If I have expression match value branches, and we handle expression value, and we go branches, iterate function branch expression match branch. We handle the pattern branch pattern, and we handle expression branch body. Can I just have over here pattern and body so that I don't forget any extra fields if they start existing there? Wait, did I already do core syntax match? Well, right now it's returning the target dependent list. Yeah. I need to like change what this returns. So in these we have a pattern and we have a body, right? Scope with target, I don't need that. Stage with target, I don't need that. So all I need to do, I guess, expression match value and branches. Okay, I say value is compile expression value, and then branches filter map. Because I'm filtering wrong syntaxes here, right? Yeah, so this returns expression match branch, which has a pattern, which is compile, pattern, and body is compile this using a new scope, but I also should inject the bindings, right? Is there a thing that's like inject pattern by bindings? I need to take a look at let. Or am I doing right now this as part of compiling a pattern? There's no way, right? There's no way I'm doing that. That would be wrong. Or am I actually doing this? When I'm compiling a pattern, identifier, we create a binding, we initialize the pattern. In the current compiler state, compiler scope, well, I am injecting it somewhere, right? How does the assign syntax work? I compile the assign, I compile the value. And I inject assign bindings. Okay, yeah, I have this. Inject assign bindings, assign. Okay. And this state. Okay, that makes sense. Match. In the core syntax match. Over here. So I need to have like this inner state for each of the things, right? So branch state is C compiler. How do I enter state? How do I enter scope here? Enter scope. Is there a compiler enter scope? It's state enter scope. Okay, it's state enter scope. Recursive is false. From the current state. And then we compiler inject pattern bindings of pattern into the branch state. Right? Pattern needs to be like compiled at this point. I inject that and then we compile the body using state being the branch state. Is this all? That's a good timing to unlurk, Nigel, because I think, maybe, potentially, what if everything is just going to work first try right now? Okay, there is one last thing that I need to do, which is to have these as patterns. I don't have the pattern, which is a variant, but other things should work. Like we have the matching already, right? Like for example, I can do something like this: match 1, 2, 3 with variable name. Then we like print int32 to string variable name, right? Like this works. It's just I need the pattern. Also, these patterns should work with like fields. So if I say x is variable name, that also should work. Yeah. Okay, I just need literally to implement the patterns of variants. That's easy. Variant impl. Variant impl over here. Yeah, so I need to be able to compile the variant into a pattern. Assign variant cannot be assignee. Still productive today. I hope DevNinja doesn't show up in chat. I believe in just, yeah, it's almost there. Hello. I'm going to have this thing working in a second. So I just need to compile a pattern variant. So we need to have a new type of pattern, which is variant. And we match the variant with label and label span, and then value is value AST into option map compile pattern, because we potentially want to pattern match the value here. So that's what I need to introduce, a pattern variant, and pattern variant as label span, and value, which is an optional pattern. That's all. If I want to print, wait, why is there a print pattern shape and print pattern and they're like the same? Because this one is with spans. Okay, makes sense. Maybe a little bit. Pattern. They're a little different. Yeah, this one is for like debug printing, and this one is for actually printing it like in the hover in LSP, for example. Better names maybe. Hello Nurtle variant. Label span value. I want to print a variant where label is this, and value is that. Label print label option print pattern with spans value. Okay, and then over here, if we have pattern variant label span is going to be ignored, value, then I print a colon followed by the label print label, and then after that we say value if value exists, then we print space followed by the value. Pattern matching. Yeah, it's almost there. Also. Alright, so now when we're actually doing the pattern matching, now we have a new pattern which is called a variant, right? Label and value is value pattern. So in this case, I need to match value shape with expected variant got this value expected variant matched full scope locals empty. Okay, so if my value that is supplied is a value which is variant, label. So this is going to be pattern label, right? Value variant. Value variant has label and data. Label and data. Type is underscore. So I say that if label dot if label is the same if this is the same label, do I just do I just check that the name is the same? What's the label? I don't have IDs here, right? We just have the definitions and names, yeah. If they are the same or not. Can I have a check whether the two labels are the same or not? I feel like it should not be based on the name here. Let's have a function is let's function same where A is variable and B is another label, and then we have inference variable. Like I need to know if two inference variables are the same basically. Are they united or not yet? Same AB. I think that's what I want. Let's in the inference have the option to figure out if they are the same or not. Let same AB is they are going to be the same if they point to the same root variable, to the same root variable data. This is mutable, so it should be like using physical equality possible, right? Let A be find root of A, let B is find root of B, and then I say this is literally the variable data. Wait, no, this is variable data. No, variable has the state. This is in, yeah, this is that. That's wrong. That's actually, wait, that's actually wrong. How do I check that they are the same? I need to find a root variable. There we go. And find root variable. The variable that points to the root. And then since they are variables, and variables have mutable state, then I am going to say that A is equal to B. Physical equality, right? A wrapper physical equality of A and B. That's what I want. Same is a var boolean. Same interpreter. Okay, back to the interpreter. If label is the same label and pattern label, then we actually pattern match, right? Yeah. Otherwise we will say matched false, scope locals empty. And then over here, if the labels are the same, then I'm going to match the pattern, the value pattern with the actual data inside of the variant, right? So I'm going to match data and value pattern with, if it's none and none, then we return matched true, but we don't actually introduce any variables. If we have some underscore and none, or none and some underscore, then matched is false, scope locals empty, because this is an error. Expected value got no value, or other way. I'm too lazy to figure out the exact thing. I mean, we can have this. Expected. Yeah, this expected value got no value, and then this other variant is expected no value, but got value. All right, and then the last variant, which where we all both have value and a pattern, then I just return pattern match recursively of this value and pattern. That's what I return. Okay. Okay, compiler init. What's the type of a pattern which is a variant? Label span value. What's the type here? It's going to be similar to expression variant. So it's going to be a type variant where variance contains at least this single thing. Oh, it's not p pattern, it's p variant, right? It contains at least this thing. And then value types for data is value map, because this is not expression, this is pattern. There's going to be pattern data type. Okay, and label span can be ignored here. Okay, nice. Compiler. Wait, what? Where is the issue? Compiler. What is that? Inject pattern bindings. That's right. So if we want to inject pattern bindings, then we want to have pattern variant label. We ignore the label, and we ignore that, and then we have value. Then I'm going to match value with none, then we do nothing. But if it is some value, then we inject pattern bindings of the value. State. Core syntax. What's wrong here? Expression should not be a constructor. Expected type is A. Because this should be initialized pattern. Span, state. Transpiler into a camel. One more to do. And then LSP common over here. Just handle the inner pattern if it exists. That's all. Okay, is it going to work? First try. Well, I don't see any red things. Look at this. I can hover on this pattern branch. And this tells me that the type of this pattern is with these 3 variants, right? No, red means good. Yeah, I think so. Can I go to the definition here? I need to make sure that I can go to the definition and rename things. That would be the good thing. It renames from here, but not from the pattern. That's in the LSP hover. If I'm hovering a pattern, which is a pattern variant, label, and value we ignore. I could be looking at the developer of the future most used programming language, Jen Caliatito. Hello. Potentially, but probably not. Label. If the label span contains a hover span, then sum, else none. And this sum is going to be span is label span. Definition mode is defined not here, label definition label. Okay. Let's see. So this means that I should be able to, there we go. I can go to the definition now. Wait, why did it open this window though? It says it opens the references instead of going to the definition, which is weird. If I try to rename this, it actually renames all of them. Wait, it thinks that this is the definition? There's no way. I said defined not here, right? Oh, maybe it's the... maybe it's... core syntax over here. Label. Yeah, because I say label is create definition. There you go. It's not definition here. It's definition if I am doing a type expression. It's a reference if I'm doing the expression, and it's a reference if I'm doing a pattern. Okay, that's going to fix it, right? Go to definition. There you go. Nice. That works. Okay, let's try actually also running this program. Cast run example variant types. Right, so what is this program saying? We say that A is none, and then I'm trying to print the variable name, right? So the none is the first line, then we assign it to sum, and if we're in sum, we assign to any, it prints any. We assign B to none, and we print none, then we assign it to any, we print any, and then we assign A to B, and it prints any too. I think this works. Where will it go if only a variant name exists? it will not go anywhere. Similar to over here. Over here, this function is a standalone function, right? Which means that this sum actually is defining itself, right? This is a different sum variant than this variant, right? Because we did not make sure that these are the same types. So the variant names, they are working differently than in OCaml or Rust. They work more like in Zig, I think, right? Where it works with any type, and then we rely on the type inference here to figure out what type is this the variant of, kind of. But we also have anonymous types, which is why the type of f here is... So the type of f, right, this takes x and returns some x, right? This returns either some or some other variants. Potentially, this can be extended with other variants, right? But over here, the a is type some or none or any, because I have explicitly written the type here, so this cannot be extended with other variants, right? If I try to say that a is like non-existent variant, right, then it's going to say that row inference failure. I mean, the error message could be improved, but it's basically saying that this is not the correct variant of this type. Can you print the payload of sum too? Yeah, I'm pretty sure I can, right? If we have sum and over here we have some value, then we... I just don't have like the string interpolation right now. So the value is already known here to be an int32, right? Because that's also being inferred over here. This over here is an int32, also inferred using this usage here. This number. If I change this, by the way, to a string, then this will be also inferred to be... a string now, right? And this value is also a string now, which makes sense. So if you want, we can print some value. Let's just print over here, return the value directly, right? And then it will return the sum value here instead of sum. So this is just an inner pattern that there can be anything here. We can have sum. And then, like, you know, field A is 1, 2, 3, and field B is some value. And then over here, I can pattern match A to be ignored and B to be value, and then we return the value, right? That's also is going to return the same thing. So I think that's all we need for pattern matching. I mean, that's not all that we need. I would never have used let as the variable definition keyword. What would you use? Let is used in a lot of languages to introduce variables. That's the most common keyword, isn't it? One thing that I don't support right now in pattern matching is having a branch which has multiple patterns, like unionizing the patterns, right? So if I try to match some 1, 2, 3 with trying to compile error node. Wait, what's the error here? Unexpected closing. Oh, there must be something inside always currently. Okay. Yeah, if I try to match, you know, some x or other variant x, right, this doesn't work because that's what I cannot do right now. So we need to have every variant in its own branch currently, but that's fine. Can you not create a void type with 0 variants? You can, it's just, this is a syntax issue. Currently. It's a syntax issue. Make destructor code action so that LSP is better than OCaml. I mean, OCaml can do this, right? OCaml can do this. What OCaml cannot do is it cannot insert the missing branches, right? If we say let foo pattern, which is pattern shape, then we do pattern. So OCaml has this code action, which says destruct enumerate cases, and then we have all of these. That's what you're talking about, right? We can do that, I guess. But I never did a code action before in my LSP, so we'll need to figure out how does that working. How does that work? Wait, what do you mean destructuring next? We already have destructuring. Pattern and destructuring is the same thing, right? Two-step. So what OCaml cannot do is if I delete some of these, then there is no code action. To fix the missing branches. That's the problem. Oh, wait, use existing match. Wait, it can. Okay. Is that a new thing? Because I'm pretty sure that was not here before. Okay, pattern matching is kind of here. Let me commit stuff. Basic pattern matching. But yeah, like I said, pattern matching is destructuring. I literally did this in this example, right? This over here. This is destructuring because this is a tuple with named fields, right? A struct with fields A and B, and I destructured it, only getting the value of the second field B. You was thinking of if let some x is x. Yeah, that's not exactly destructuring. If let is technically the if it's technically just the syntax sugar, but not exactly, right? If you say if let some value be A, then in this situation I would have fixed up. You mean amended? Yeah, I just already pushed. I don't amend if I already pushed. Usually. Whatever. Yeah. The if let is a nice thing. It's not super important to have though, kind of. And also instead of an if let, I wanted to have the is operator. So we say if A is some value, right? That's what I want. Yak, yet another C killer. My language? No, it's not a C killer. It's more like a Haskell killer, and OCaml killer, and Rust killer. I guess. Functional programming, boys. Yeah, not exactly functional, but also functional. Rust killer? Why would you want to kill Rust? Because Rust has issues. Didn't you see the latest Cloudflare problem? Where it all happened because of Rust? The entire internet went down. So we need a better language, of course, obviously, right? Which wouldn't let the internet down. C++ is a better language than Rust. Smiley face. Well, if you like living in the world of lies, then sure. Function Cloudflare with cannot let internet down. I mean, yeah, having the E flat is a good thing. Is that what I do though right now, or do we try something else? What else would I do today? You say it's advent of code ready. We can try solving the advent of code, like from 2024. I still did not finish that. This also requires lists as the next thing. That's what I don't have yet. Our languages are bad compared to Cast. Indeed. With the only minor nitpick that Cast doesn't exist yet properly. It's not implemented fully. But other than that, yes. Can you not make a linked list now? Yeah, I guess I can make a linked list using the variants, right? I can. Yes, I can. Split white space. Yeah, also we don't have the for loops done with effects, right? So over here, we have the lines, which is just a function that takes the consumer instead. But that's fine. What exactly is Cast aiming to be as a language? It aims to be the language. All right. What do we want? We want to be able to do everything. All right. How do you actually describe what we're making here? We want to be powerful, right? Which means being able to write high-level abstractions. And also there is a lower priority goal, which is also being able to write low-level code, but that's lower priority. The higher priority is being able to be high-level language. Is it object-oriented? No, it's not object-oriented. You want to cast my thoughts into unbreakable code. Well, I mean, I was thinking of adding object-oriented features too, but like it's like no one in the current modern world thinks that object-oriented programming is good, right? As far as I understand, no one wants it anyway. So like, why would I add it? There is no sane person who wants object-oriented programming, right? Affirmative? Like, I think people generally agree that object-oriented programming is dead in 2025. It's only like alive because of like a legacy code that is written in object-oriented languages. You do sometimes see advantages. All right, yeah, I feel like there could be advantages in a couple situations, but what are the situations? Well, I mean, technically, object-oriented programming is still used currently on the web in JavaScript, right? There are inheritance like in the web APIs. Where do I look? TypeScript in object-oriented style. Yeah, like the DOM itself is the object-oriented, right? Web DOM API. Like, how do you model the DOM if not using the object-oriented programming here? So just because of that, we need to have object-oriented features, right? Kind of. If you look at the languages that do it without object orientation, like Rust. So for example, we have the body element which is still an HTML element, right? So we have body. HTML body element. So in Rust, this is done by implementing a trait. Oh, it just derefs. It just derefs to an element, I guess. Is element the same as HTML element? Or are there different elements and HTML elements? I guess element is just the element. Object-oriented programming is necessarily bad. Polymorphism is bad. Why is polymorphism bad? And well, in general, when you talk about object-oriented programming, like what is object-oriented programming? What is object-oriented programming? What's the definition of it, right? Because similar to functional programming, right? Is my language that I'm making functional? I don't know. What is the definition of the functional programming language? The functions being first class? That's true for a lot of languages. But the core principles is encapsulation. And encapsulation can exist without a language being object-oriented, right? Composition can exist without having object-oriented languages. It's the inheritance, basically, which is the property of an object-oriented languages that is not used in modern languages mostly. The other features of object-oriented programming are present. It's just the inheritance that is considered bad usually. Anyway, we'll see if I add inheritance to my language or not. But so far the plan is to focus on other things. I mean, let's try doing the list here. I can later change the implementation of a list using like some more native thing or whatever, but we can do it like the functional languages do it already, right? Let's just have a standard library thing that's called a list. So standard library. Or do I do collections? Let's do collections. And we'll have a list over here. So standard library will have a module collections. Include collections like that. And then we go and say that list is include list. Like this. Maybe later we will add something else. So we'll have a module, right? And what do we want? So first of all, we want to have the type. Type t. Type list is either cons, or it's either an empty list or it's cons variable of type t And yeah, so like value t, and the rest is a list. Okay, I actually cannot do this yet. I think we need to do this. This is because I don't have recursive types yet, right? So this also list must be a generic thing over t, and then the rest is list of t's, right? I think this is what I never implemented. It should be easy to implement the recursive ones, though. And this should be a type. Right, like that. There we go. We just go and say that generic is not compiled yet. Oh, wait, generic is not compiled yet. Yeah, that makes sense. Are you gonna do implicit boxing? I think it should be implicit boxing here. I mean, for types specifically, right? We want the recursive types. So whenever I have a type expression like this, it needs to... So right now it tries to evaluate this type directly. But what should happen is I should initialize this type to a not inferred variable and then do this in a separate potentially background thread, because we have a recursion here. And then I say that it's equal to this thing, I think. Right? And then this way the function can be compiled, right? Because right now I cannot compile until I evaluate this. Right? Oh, wait, also, isn't await compiled completely not implemented currently? Await compiled. This also has a to-do. Yes, function is not compiled. Is cast lazy? Not exactly. No. It's an eager language, but it is it has the possibility to pause. Like, it's an async language. It's not lazy. Okay. So I think first thing that I need to do is implement the waiting for the function to be compiled. How do I do that? Are we inside of a maybe compiled function? Inside of a maybe compiled function, we need to store the things that we do on update on compiled, I guess, is a list of functions that need to be executed. So if the function is not compiled yet, then I need to perform the effect await compiled. In polymorphic LC that make recursive type using some type wizardry. What's LC? And recursive types to system F. No, I think I understand how to do it. I just, well, I mean, okay, maybe like there are two things right now. In this specific type that I'm trying to do, the list is trying to be also a generic type, right? A generic type means that this is a generic, and generic needs to be like compiled and whatever, which is why I'm doing this await compilation thing. But we also can try first to have a recursive non-generic type. That's a little easier, I guess. Maybe that's what I do first. That is done inside the language, not inside the interpreter. Well, for me, language and interpreter is the same thing. Interpreter is part of the language. Interpreter is important. Oh, I could try doing this in cast. Oh, you mean like in the language, like in the language? What does it mean even? With a simple way to add recursive types to system F without going the full ADT route. My basic idea is to add fix to the type language and constants fix in and fix out to the expression language, such that, for example, fix for all t at would be converted to from a into fix for all t a into t. What? With this extension, you could have a Scott encoding of lists like this. A list of a is fix for all t for all r into atr r. I have no idea what this is talking about. Extends for fixed point. What's a fixed point mean? I don't understand this. I don't know. Is the opposite of float point? I don't think that's what it is. That's different. Why would you do... No, that's not what it means. Let's try this. Let's just have a list. Is an always an integer, right? So it's a type which is empty or ons value of int32 and rest is a list, right? That's what we want. This requires the parentheses, right? Okay. So now this just says that we cannot find list in scope, right? So that's what it means by not supporting recursive types currently. You think f is a fixed point if fa is if fa is a fa? What does it mean? Why would it be useful? That's some functional programming thing, like, I don't know. It's too smart for me to understand for my little brain. It's too theoretic or whatever. I need to read a book about fixed points to understand it and have a PhD. Okay, so list would not find list in scope. So there you go. Here's what I want. Here is what I want. It's also done in untyped language calculus to add value level recursion using Y Combinator. Yeah, whatever. It can be fancy if it works with lambda calculus. Lambda calculus is already fancy. What's a Y Combinator? Like it's a specific like function, Y Combinator. That's what it is. The lambda f, lambda x, fxx into lambda x, fxx. Makes total sense, right? The classic untyped lambda calculus. Lambda calculus has like 2 rules. Well, I mean, okay, it's not fancy, but it's like we don't think in terms of lambda calculus, basically. Or at least I don't. The same reason why we don't think in assembly, for example, or in a Turing machine. So what should happen here? I should be able to see this list in the scope, because this is a recursive scope already, right? Sometimes I want to also specify the types not inside the recursive scope, actually. Which means that I need something like letrec, after all. Let recursive. We'll figure it out. For now, just do it inside these modules. So I just need to do what? A type expression. This thing should be evaluated separately, maybe? It's an infinitely recursive expanding structure, but because of laziness in lambda calculus, you would not expand it immediately, and it is able to terminate when the function passes to it terminates. Yeah. Have you been reading a lot of type theory or something, Nigel? Have you been watching too much of Eduardo's streams? When are you going to create your own language? Now that you are fluent in lambda calculus? These videos, not streams. Okay. Let's see. Fork. I want to fork in the core syntax of a type expression, right? Isn't it any type expression can be forked? Because all the type expressions eventually resolve to a type. Okay, Haskell killer. Oh, you don't need to understand lambda calculus to be a Haskell killer, right? Well, and I didn't say that I don't understand it. It's just like in order, like one of the problems with Haskell is that it's like too smart, you know? I moved to simply typed lambda calculus, but I find it quite boring because no polymorphism. Now I'm studying polymorphic LC. All right. Read previous message. I was able to write an untyped lambda calculus, but got demotivated to use it when church numerals took 10 minutes to calculate 1000 plus 0. So like all I need to do is a fork somewhere. I need to do a fork somewhere. Where do I do this? I do this when I compile. Bound constructor. Let me have this in to do because I also started this stuff. Let me finish what I started first, I guess. Okay, yeah, this works. So I think somewhere inside of the compiler, when I'm trying to compile, so I'm trying to compile something into a type expression. But it's like similar to the bodies of the functions being compiled later. Yeah. So I need type expression. So type expression is potentially compiled later. Right? And not immediately, I think. So a type expression should have a mutable field shape, which is expression shape option. I will call it, compiled shape then. And then we have similarly on compiled is a list of functions so that we can wait for it to be compiled. That changes things though. When I try to print the type expression, we have a compiled shape. And then we're going to match compiled shape with some shape, then we print it like this. But if it's not compiled, then I should say that it's not compiled yet. Still have the span though. So when I do the interpreter, in order to evaluate the type expression, I need to await compiled type expression. Right? Await compiled type expression. Expression. This is going to return type expression type expression type shape. Yeah. So we just do effect perform. Await compiled type expression. We'll need to say type effect t plus equal await compiled type expression, which is going to be type expression type into expression type shape xt. Okay, maybe I just do them at the same time. We have await compiled and await compiled type expression. This is just waiting for compilation. The maybe compiled function and returns a compiled function. This would be just effect perform await compiled path. Dun, 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 dun. That's all that we do. Why do I have the span here? To report the error. I should still report the error if this never, like, the awaiting never happens, I guess. And what do I return then? Though, what do I return then? Like a function. Oh, well, I mean, in this case, I return a none. Yeah. And this should also return the option then. I'm not sure. This function application is partial. Span is expression data span. Okay. Compiler init. When I'm initializing the initialize type expression, does it mean that the type expression should be done completely differently though? So I need to, instead of initializing type expression, I need to have something like create type expression. Which would have a span state, but not the shape yet. Like, it should have a function that actually calculates it, because that's what I always want to do, right? That's what I always want to do. Yeah. So instead of having over here the function type shape, we instead have a function that returns the type shape, right? That's how we calculate it. So we initialize. Wait, why do I match the shape here? If it is an expression, then we expect that to be inferred as a type. Okay, yeah. So I think what I need to do is say that over here, that shape is none. Compiled shape is none. On compiled is empty list, right? Then I would say this is the result. And then I would do fork or whatever. Some kind of fork. Let's do for now, just I call this immediately. So I just fork using a function that that tries to have this shape, that tries to calculate the shape. Let's call this function. We see what this is. That shape we shape called. Then I match it. But also I say that compiled shape result compiled shape is some shape now. And we also call all of the uncompiled. Result on compiled. Let's F is result on compiled, result on compiled is empty list. F's list iterate function F. Just call all of these functions. Result is of type expression type. So now type expression error, we say instead function that returns type expression error, right? Interesting. Okay, so now whenever I do core syntax, we need to initialize type expressions. So this compilation of the expression should happen in the background, which is why this is going to be a function that compiles this, right? This should be a function that returns that and compiles it in the background potentially. Type expression const. This is type non-inferred constant initialize expression compiler state. I feel like all of this should be function returning this type expression. If we have a type expression for the function type, that's what I do here too. I literally just do this all the time. Just do function that returns the type expression like this everywhere. And make sure that nothing effectual happens before type expression unit. Like over here, for example, right? We have type. What is this? This is a type. Oh, it's because it's a const here anyway. Yeah, I guess this doesn't matter. I guess this doesn't matter. Here. This is a dot syntax. So this can compile background, sure. This. When we have a tuple field, we also do that. And then here for the comma impl, this I'm just going to do that, whatever. Value AST label, that's probably fine. Function into that. And then this over here is a union. So yeah, here I have compiled before. But maybe I should have compiled this. That elements. Well, union must be type expression right now. So we can just do function that returns all of this here. And then over here we have function let elements be elements in that. Okay. Fast compiler. So now over here also I'm doing the type expression. Compile state expression AST. What is this? If we have a simple token, we have type expression. Compiles as an expression. Yeah, whatever. Yeah, this is where we fork because I'm waiting for the thing. Or the identifier. LSP common. So LSP common, this now going to be match compiled shape with some shape, and then we match shape, I guess. And then if it's a none, if it's not compiled, this is going to be compiled shape, right? So if it's none, then what do I do? This is inner compiled with handler. I just don't do anything. Makes sense. And LSP hover, if we have type expression, get tuple. There's going to be some type expression tuple, I guess. Compiled shape. Hover specifically if compiled shape is, in this case, some variant. Okay, so this is a success, but this is not going to run. It's going to have the unhandled effect. Await compiled type expression. So I'm going to handle this effect now. Okay, and then we say let fork f be f. So this needs to be like also changed. And we have that in the interpreter. Command let fork. So we have a fork in inference, we have a fork in compiler, and in the interpreter. Well, I mean, technically this should be just state.fork. State scope fork. Is that what we want? That's probably like not that, but we want, yeah, we do the inference fork, and we also want to do the interpreter fork then. Cast interpreter fork on the outside too. So now in the interpreter, I should have the function fork f, which is unit into unit, returns unit, is just going to try call function f with effect await compiled function continuation. In this case, we do function uncompiled. Uncompiled. We append to this a new function which does effect continue k. Effect continue k using f compiled. Let's just do unit here. But it means that this effect, which I cannot go to the definition for no reason, will always return unit, because this is just waiting for it to happen, right? Which means that over here I am performing this effect, but then since I have waited for it to be compiled, I can return f compiled now, right? And over here I am performing this, and now expression dot compiled shape option get wrap or else option, just option get, whatever. I will panic for now. So I need to handle this effect and handle await compiled type expression. Expression K. We say expression on compiled is this. That's all. Vertical bar over here. And this is expression uncompiled. What I'm doing right now, by the way, is recursive types. Backdoor, hello, hello. Okay, so what happens if I do this now? Unhandled await compiled type expression. When I'm trying to do this, unwind unit is this type, right? Oh, sorry. Did I never fork it? Oh, wait, I forked it, but awaiting the compiled thing happens in the other place, right? Also, I need to also only perform the await compiled if it is needed. Right? So I only need to do this if f compiled is none. Then we do perform this effect. If expression compiled shape is none, only then I perform this. See what happens next. Okay, so now it's trying to compile this, which is literally the list, right? That's what I'm trying to do here, the recursive type. And it says that we have the unhandled because it could not finish compiling this. Okay. So we just say that because we are evaluating a type. And stuff. Include compile module statement and things. I think I know why though. It's because now in the yes, in the interpreter. In the interpreter, when I evaluate the type expression, right? When I evaluate the type expression, I don't necessarily need to await it immediately. Yes, I don't need this. I do not need this. What I should do Wait, there is also a substitute in the bindings here, which is weird. Okay. Result. I think basically that result is we initialize a new not inferred type, and then we fork and do in the background waiting for the compilation to happen. So this should return the type, right? So we just say that result inference type x. We don't have that here. Result variable inference variable x infer as different. This depends on cast inference. What is inference? Inference is cast inference base. Can I just use the inference here like that? Instead, inference type expect inferred as span is expression data span match. That does that work? That's just the result then. Okay. Well, it is compiling. Is it going to work though? Who knows? Of course not. Raise that effect, deep discontinue. Okay, that's actually a different one. Oh, list not found. List not found over here. This thing was not found. Why was this not found? It should be found. It's because I didn't fork. Wait, but I forked it. Oh, but it's a const, which is a different thing. What's the fork? What's the fork? It says cannot find the list in scope. That's because I'm discontinuing. And the reason I'm discontinuing is because I have a handle effect over here. Await update. Wait, await update in the compiler scope returns a boolean. Oh, boolean because whether it's... Wait, why does it return a boolean? Whether it should keep updating or not. Yeah, okay, makes sense. Yeah, because this is the thing. A list is not found when compiling expression const. When I'm it's interpreter error. It's not a compilation error, right? Yeah, that makes sense because we want. So when we see const, this thing is trying to evaluate this expression immediately, right? I'm trying to evaluate this. This is not compiled yet because we're waiting for the list to be defined. So list should, like what should happen is that it should be initialized to be a not inferred type. Then we define it, we finish compiling this, and we so I think everything should work. I don't understand what's happening. How do I debug this better? How do I debug this better? It says list is not found. Another word will start with R and ends with E. Rewrite from scratch. I feel like the language is slowly getting there where we can rewrite the language in itself, kind of. Right? Like, isn't the recursive types literally the last thing that I'm missing? And then we have a language that's working. Or am I missing something else? I don't know. I mean, there is like a bunch of like native things that should be implemented in the interpreter or like the transpiler if we want to the rewrite to be compiled, right? Then we need to like transpile it or whatever. Transpiler will need to be finished. I don't know what else is missing. Probably just have a bunch of bugs currently. List not found. That's an interpreter error. It's an interpreter error that list is not found. Wait. I know why. Interpreter is not waiting for the recursive scope to close. Right? I'm just trying to evaluate this immediately. Because this is interpreter scope. Find local, right? Opt or whatever, something like that. What is the error? Not found. in the interpreter over here, right? When we are trying to evaluate the expression binding, I'm trying to find this thing in the current scope, and then it is not found. Because this thing is not even trying to wait for the symbols to be defined later. Is the compiler written in the language itself that you're building, like Golang? No, not yet. We are in the early phases of making a language. I'm just trying to implement some basic features right now. Like being able to have recursive types. Like Golang. Why out of all examples you decided to choose a Golang as an example? Every single popular language today is written in itself. You love Golang? I don't. But if you do, that's good for you. You live a happy life is what it means. And I hate every single language, which is why I'm making my own. Every single popular language these days is written in itself. What about a language like Python? Python is not really written in itself, right? I mean, there is PyPy, but people mostly use the CPython, which is Python written in C, right? Python is trash. Well, that's an opinion. I do agree with that opinion. But other people's don't, just like you don't agree with the opinion with Go that Go is trash, which is my opinion. Similar thing with JavaScript. Yeah, JavaScript also is not written in JavaScript, right? I mean, basically none of the dynamically typed languages are written in themselves. Like, is Java written in Java? Is Java written in Java? Because, like, how do you get the JVM, right? The Java compiler is indeed written in Java. But the JVM... Is the JVM written in Java these days? Because, like, there are some Java compilers that can output native code. Probably not, right? It's probably still written. Is JVM written in Java? Yeah, still in C++ and assembly. Makes sense. So not all popular languages are written in themselves. Bum, 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 bum. Lua is written in C. Yeah. Lua is not that popular. Oh, I mean, it's kind of popular. But like Java is obviously more popular than Python and JavaScript, right? Alright, I'm trying to do recursive types here. My compiler architecture is async. which means that we sometimes fork and like compile these things in the background. So when we are looking for the symbol list, which is not found here, we are supposed to wait until this scope, which is recursive, is finished being defined, and we can just do this. Actually, this means that this expression was compiled, but it's, yeah, like, because I have the interpreter error. It has been compiled, but it cannot be interpreted. How do you even know what to do? Started programming a year ago or so I'm completely out of my depth here. How do I know what to do? I don't know. I just do things, and then I figure it out as I go. I don't really know what I'm doing, if that's not obvious from watching the stream. But I don't know. Like like what I know is I know what I want to make, right? Yeah, you just keep doing things that you're able to, and if you're like stuck very deep, then you ask for help, which includes like looking things up, how other people do similar things, right? Or just talking to people, or like, I don't know. Being able to figure out things is an important skill, I guess. So yeah, it was compiled. This thing was compiled, but it was not interpreted, because what happens... This, by the way, is a const. A const is a little bit different than a let, because it tries to evaluate this immediately at compile time. Which... Yeah, I feel like I also need to have very similar thing to the compiler, where when I'm trying to find it, because like the scopes in the interpreter, I don't say that they are recursive ever, but I should. As in, when you decide, oh, I'm gonna build a compiler, that's a term. Like, how would you even know what to do? When I made Bitcoin, I had to go read source code, the white paper, and do a ton of research. It was fairly new, but I see people just know what to do, which is mind-boggling. Should maintain a reasonable balance of reading books and doing your own thing. I don't think I'm doing the balance here. When you read lots of theory, you start thinking, I need to do it the way book says, because that's the right way. Is that a good thing or a bad thing? When you read too many books, you become locked to the way the books tell you how to do things. And you forget that there are other ways. So you don't even think about the other ways then. So that's a bad thing, yeah. So I think you just should try to figure out how to do things as much as possible on your own, and only look things up when you're stuck. But it also depends on the goals. Like, sometimes if you want to get to your goal faster, it's easier to use an existing solution than reinventing the wheel. So I think what I need to do is my interpreter scopes can be recursive, just like my compiler scopes, right? So here's my interpreter scope. Currently we have locals, we have a parent scope, right? And that's all. If we take a look at the compiler scope, over here, then compiler scope is a little bit more involved. Let me move this thing closer to the interpreter scope too. So this is the interpreter scope, and this is the compiler scope. Compiler scope has also parent scope, which is similar, which it has bindings, which is similar to the locals. And then it can be a recursive thing, right? Because we can have recursive scopes. Yes. I feel like I do the same thing. The interpreter scope can be recursive. And then we have closed and on update thing. And then compiler. And then so I need this code. To be copied into the interpreter. Find a local opt. Let's see. So basically, when I look up a symbol in the scope, it is either existing or it's not existing. But if it's not existing, it's potentially just doesn't exist yet, and it's going to exist later. When you made Bitcoin, Satoshi in chat confirmed. Hello, Raymarch. The language is starting to feel nice. As if I do this recursive types right now, I feel like we are getting somewhere. Did I push everything? I think I can like show things up on the playground. What was the last thing that I did? We have the variant types, right? Variant types over here. I can copy this into the playground, and then it's going to work, right? Can I disable the type ascriptions? I feel like I want to disable the type ascriptions on my playground. It's a little annoying. It makes this too long. But yeah, I did finish the sum types over here and pattern matching today. And we have all of the LSP things working for it too, so I can like rename things and stuff. That's so nice. I'm just missing the recursive types now, and then I will be able to do everything. So yeah, when I'm finding the local variable in a scope, it's either there or it's not there. So let's see, I'm trying to find it. And if it is there, then I return it immediately. Rust has already lost. Yeah. So yeah, find in parent is scope parent, and then find local opt. from ident should be just be name. So instead of find binding opt, we use find the local opt. Name. Scope parent. And then find local opt name. Parent is optional scope. Hello, peer. Find in parent is unit into local option. Yes, that's correct. What is my editor has? It is weird explosions and everything is going on. Just for fun. Because why not? It's an extension called power mode. Shows the explosions. And shakes the screen a little bit. This should be another effect now, right? Type effect t plus equal await update. This is going to be unit into boolean effect t. So if it returns true, then we can continue. Otherwise, we stop looking in this and we go look in the parent. Await update. This should also give me the scope. So it should take scope as an argument and return boolean. Okay. But what is why is this? Find in parent. Oh, it's probably just because of that. I need to remove that. Okay, there you go. Easy. Here's HDHDs. Why? Okay. When I initialize a scope, right? Enter in the interpreter. How do I enter scope? Common. Enter scope. Oh my god, I hate OCaml language server. It just doesn't work. Enter scope. Let's stage with a new scope. Okay. Okay, so when I do this, I will initialize recursive with false. On update is an empty list. Closed is false. Ethereum is cool. It has the EVM. I'd also like to someday know how it works internally by making it myself. And then I also need to be able to close the scopes now that are recursive. So similar to the compiler, we have the function close, which should notify updates. Scope closed is true. We should notify update. Just like that. We call all the functions. And then I need to have the function fork. is just going to try evaluate the function. If wait, update scope k, we just do that. And then in the common, I have a fork in the end, which forks all of these things. So it also should do scope.fork in addition. The only reason I chose Bitcoin was because that's the only one I had heard of, and the story behind it was compelling as to why it was made. Alright, so when I enter scope in the interpreter, it should have recursive, which is a boolean. And then over here we say recursive. Closed is false. On update is empty list. Any flag 82. Hello, what are you developing? I'm making my own programming language. Hi. Did you know Eduardo also works on a smart contract language called Lego? Yeah, I know. But I don't know anything about the smart contracts things. I'm not really interested in like the crypto stuff. I just don't care about it. I didn't look things up there. I only have a very rough understanding of the crypto. I mean, okay, like the blockchain, sure. I guess blockchain isn't necessarily crypto, right? Yeah, I don't know why I need to worry about blockchains. And yeah, I guess it's like it's just not interesting to me. That's all. Okay, I don't want to look into it for some reason. Crypto is only fun if you do the networking and all the cool stuff. Contracts feel boring. You can think of them as distributed computers. Yeah, but like, you don't need a blockchain for doing distributed stuff, right?
Activate Linux? What? Windows took Linux no.
Windows took Linux? No. Interpreter common. We have the problem on line 216. Over here, evaluate state. Why is this a problem? Oh, because state is state enter scope. Enter scope recursive is false. But when we do an expression module, this is when we also are supposed to enter the scope. Module scope is scope init. Oh, wait, I do scope init. Okay, let's do over here recursive. 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 So over here, scope init, recursive is going to be true because that's what modules are. They are recursive scopes. Over here, when we call untyped functions, this recursive is false. When we do the pattern matching, we don't do any recursive scopes here. Unwindable, inner state, enter scope, recursive false. You like contracts more than networking? I feel networking and consensus are for super brainy theory people. Also ZKPs. Recursive for a loop is false. Oh wait, not here. Enter scope, recursive false. There you go. Scope with target in it. Recursive is false. Zero knowledge proofs. Okay. Cast interpreter. Recursive false. Originally, our interpreter is in a not recursive scope. And by the way, when I do recursive true in over here, right? Recursive true. Whenever I do this, I need to close the scope. When I finish evaluating it over here, I have finished evaluating it. Module scope locals by symbol to list. Yeah, I need to close it here. So we do scope.close module scope here. Okay. Let's see if this works. Maybe this is going to work first try now. The list is not found. Beautiful. It still doesn't work. Cast interpreter. Scope. With values. Like, I want to figure out why. Oh, wait, maybe also. No, never mind. Never mind. Wait, maybe it is. How am I doing this in the compiler? Because in the compiler we have the interpreter, which is driving the compile time evaluation. So what happens when I have the core syntax module? Right? Because I am entering the scope recursive true. Right? And the interpreter is not entering the scope here. That's the problem, because when I'm entering the scope in the compiler, the interpreter should also enter that scope. What's ML? It's OCaml. Hello, Hunter 1749. So when I do recursive, I need to change the interpreter, because interpreter needs to enter scope recursive. Interpreter, right? That's what I need. Let's see if that works. Okay, now we have something else. Now we have an unhandled exception, cast interpreter, scope, await update. This is a little weird here. Why is this effect unhandled, right? Because in cast interpreter, scope, await update. Wait, and when does it happen? Oh, it actually happens over here when I'm trying to compile this. Oh, yeah, I see. Actually, this kind of makes a little bit of sense. I need to have effect, await update. Over here, it's not compiler scope, it's interpreter. Scope await update also should just continue with false. That's like the default handler. Should be done here and in the JavaScript, I guess, too. Let's see if this works now. Okay, now we are back to the old error, which is list is not found. Okay. Oh my god. The list is still not found. List is not found. Why is it not found, right? Because this over here should have done the recursive scope. Let me make sure. And that's what's happening. Interpreter, maybe like I can debug here. If the thing that I'm trying to look for is the list, then I will print something here. Right, so it is not found here. Okay. Well, let's see. If name is a list, then print what? List not found. Scope recursive. Can I write a boolean like this? Recursive and closed. Let's see if it's recursive and if it's closed. Right? Wait, this was not even printed. This is not even printed. Now that makes no sense. It means that I'm finding the local variable without using this this thing. Okay. Am I like accessing the field directly? And it's interpreter error that list is not found. Not found in the interpreter, which is over here. This is where we're getting. Log trace all in scope is this. Let's log everything in scope info. So all in scope is std unwind init loop block bool int32 char string op cmp io string path fsys rng. And what is this? What is the carrots? Carrots is when I'm going the parent. I see. Yeah, so nothing is in this, but in the parent scope we have std. Is that what it means? Wait a second. Wait a second. Here's the code. You know what? Let me do this for now. Const list is to do. Let me do this, right? Because that is going to work, right? Let's instead run examples. Let's have a new example, recursive types, right? And just debug it there instead of debugging it in the standard library. We have a mutual recursion, that's recursive functions, but now we want recursive types. Recursive types. Recursive types. I need, what will your compiler interpreter target? Machine code directly? Eventually it will directly do that. But right now I only have the interpreter and the transpiler to OCaml, which is not finished. There's also transpiler to JavaScript, which is probably going to happen. Yeah. Yeah, native compilation is planned, but it's far in the future. But it's supposed to be target independent based, kind of. So it should work with any target. That includes, for example, not only like x86 and stuff, it also includes the GPU programming. So like writing shaders for games using this language. It's not only the programs that run on the CPU that I want to do here. Okay, so recursive types, we just say const t is type t and t. Can we do this? So this is going to say that t is not found, of course, right? It says that t could not be found in scope. Well, I mean, that makes sense because this is not a recursive scope. So, but if it is recursive, which is done by doing the module, then we got rid of the compilation error, but we now have the interpreter error. So this has been compiled, but it's not running. So t is not found, and we don't have anything in the current scope, but in the parent scope we have std, right? Parent scope is the parent scope of the modules, which means that this is never done. Okay. Interpreter. Find opt. Oh, it's because I'm doing scope find opt. Oh, wait, no, but this is using find local opt. Wait. Welcome back, Penguin. I don't get it right now. All in scope. Let's also, when I do print all, I want to figure out if it's closed or not. Closed is this, which is scope closed. Recursive. Scope recursive. Okay, let's see what is this going to tell me. So this says that recursive is true, closed is false. Okay. So it is not closed, and when the thing is not closed, it makes sense that we cannot find it, because it means that I'm evaluating this before I'm closing the scope. That makes sense. All right. But why is it not waiting? Because if closed is false, then find local, right? So we have not found it, and scope is recursive, and scope is not closed, which means that I am going to perform the await update, right? It means that perform await update it means that this is not handled. I'm using the global handler here. Is it because this fork is not used? This fork is used over here, right? In the interpreter fork. An interpreter fork is supposed to be using in the compiler fork. Are we adding a not inferred T to scope before interpreting? Yes, that's exactly what I'm doing, right? So the way this thing is supposed to be evaluated, it's something like this. It actually does const T is, you know, like not inferred, like this, right? Then, and then we evaluate this. What is TT? And then we assign T to be equal to this, because we can only do this after this is defined, right? So we are waiting before interpreting this for T to be defined, right? Which is why I'm waiting for the scope to be closed. So yeah, I mean, I'm supposed to be initializing this to a not inferred variable in the meantime. But it's not waiting for some reason, which means that this is not happening. What if I do over here? Print this. Like, am I even getting here? I am getting here. Oh, wait, I never call on update. Right? I never... Wait, no, I do. Notify update. Do I close the scope? I close the scope. Oh, I never close the scope that is inside the compiler. I never close the scope that's inside the compiler. And also notify update should also happen whenever I inject the binding, when I'm adding a local over here. Since locals are being updated, I also want to notify update here. That's another thing that I could do. So right now it's only going to see this after I close. Let's make this work first. It means that in the compiler, when I'm closing, it's not only closing the... yeah, this is closing the scope. Yeah. Inject binding. It's go recursive, then this. Else close scope. I guess that doesn't really matter. So closing of the scope is happening over here in the module. It's just like this should not only close the compiler scope, but also the interpreter scope. State interpreter. Interpreter scope close. State interpreter dot scope. Like this. I need to close both compiler scope and interpreter scope here. Let's see if this fixes it. What did I just do? Why is there a syntax error here? Inject binding. Print closed scope. All in scope. Recursive is true, closest false. I'm still looking. And closed is still false. Closed scope. Closed scope. Print. Print all scope. And scope closed is true. So yeah, let's see this. So I close this. Recursive true, close this true. There you go. We have std. Oh, wait, look at this. T is over here, right? Here's where I'm closing it. I'm closing this scope with T being in scope. But I'm closing it after it is not found. And that makes no sense. Maybe initializing empty scope instead of passing it down. No, it's not waiting for the scope to close for some reason. This is some scopes in the standard library that are being closed here. So this over here, right? It says T is not found in this file, right? And all that we have in scope right now is that this... so I'm currently in this scope, the scope of the module. It's a recursive scope that is not yet closed, right? So when this happens, I'm supposed to be looking... I'm supposed to be waiting for the scope to close. Right? Waiting. But it is not waiting here. This is a weird bug. The effects in OCaml are difficult to work with because they are like untyped, I guess. They are invisible to the type system. I think that's the reason. So I'm using the default handler, which I'm introducing in another place right now. Close. Closed. Closed is false. Let me do also over here, right? Find local opt. Am I using the preprocessor or is the effect native OCaml? It's native OCaml. It's introduced in OCaml 5.3, I think. If scope recursive and not scope closed, then we perform the update awaiting. And then we try to find it again. That makes sense. Let's call this something instead of T. TTT, for example, you know? So that I can log it. You know? Let's log here. Print looking. Let's do this. If name is let log be name is equal to TTT. Right? If log, then print looking for TTT. And then for here, I say if log, then print TTT found. And over here, if log, then print TTT not found. Over here, TTT recursive and not closed. And then over here, I will say TTT awaited update. And over here, I say TTT, await update returned false. Let's see what happens. It's not pretty closing, maybe. Wait, wait. This is not being printed. No way. Why is this not being printed? That's what I'm looking for. TTT, right? Hello? Am I not executing this code? Name is TTT. So I'm never looking for this. Wait, I'm not using this. But isn't the error TTT not found? Not found. Like I'm literally just not using the code that I'm writing, but I'm using some other code. What is happening? This is where we get it, right? This is not found. And what we're doing scope.findOpt. Find opt is this, which is calling for find local opt. Right? If binding name is TTT, then print looking TTT. That should be happening, right? But it's not happening. Wait, what? That makes no sense right now. Print looking for binding name. Looking for TTT. Oh, it's physical equality. I'm stupid. This is... Oh, I hate OCaml. It makes it so easy to write a bug in OCaml. Instead of a double equal, I need to do a single equal here. I hate it. Okay, I'm looking for TTT. TTT is not found. Then it is recursive and not closed. And await update returned false. That's what's happening, right? Why is return update... await update returned false? That makes no sense. Okay. Why is this returning false? Why is this returning false? So I'm trying to evaluate this thing, right? In the interpreter, I'm trying to evaluate the type expression. Because that's what we have here. This is a type expression. Right? And when I'm doing this, I'm always forking. And since I am always forking, I'm calling this scope fork, which means that all the await updates inside here should return true. Let's see over here. Print await update registered. TTT is not found, recursive and not closed. And this is not registered, which means that I'm not getting this handler. Time to audit all occurrences of equal. Yeah. Effect await update. Okay, so it means that I am doing this outside of a fork, but how can I make this... How can this be happening outside of a fork? Because fork is literally used when I evaluate all of the type expressions. I don't get it. Let's say over here. Print. Forked at span print expression data span. Tell me that I forked there. Forked at... Yeah, I actually forked multiple times here, right? There is a 19 to 27, which is this entire comma. I fork for the first and for the second. I forked 3 times and then I started looking for TTT. TTT not found here and TTT not found there. We have 2 errors. Okay, so, and since I forked... Wait, this is weird. If I fork... But it says, but it is forking another thing immediately. It's like, it should only... How does Rust deal with this dilemma? With what dilemma? I don't know. In Rust I used async. In this I'm implementing like my own async using the effect system. Rust could... Rust also has like problems, but in Rust I know if a function is async or not, at least, right? I don't know. Never mind. Like for this... Oh, you mean like the dilemma of equality? stdlib only does structural equality. Physical equality is just something that doesn't like... It's not been used in Rust at all. I feel like they should just disable the double equal from the standard library. Can I like disable it? Or whatever? Like I want the double equal to just not be possible to use. Because they have introduced a new thing which is called a wrapper.physical equal, right? When I want physical equality, I want this to be explicitly done with this function and not with the equal operator. Does fork start a new OS thread or what? It starts a new async task, I guess. Tyvex, do you have a portfolio website? Not really. You can look at my GitHub though, I guess. It doesn't work. You just find Kuviman on GitHub and see what's there. How do I debug this? Why is fork not... Yeah, so fork is an async task, right? It's kind of similar to creating a thread. But it is cooperative multitasking, so it still all happens in the same thread. My compiler is still single-threaded here. A type got error. How long am I debugging this issue for? For an hour already? I'll figure it out. type. Like, I am evaluating this thing. Absolutely binding state result. Result is the new not inferred type. We fork. Oh, it's because I'm waiting for this to be compiled. That's why. Yeah, okay. That makes sense. I was waiting for it to be compiled. Which happens when the compiler, when compile time, we do this, then we try to evaluate it. And that, in this case, is an expression. And then we just try to evaluate the normal expression here. But we're still inside a fork. I don't see the issue here. I don't see the issue in my code. Maybe what I need to do is I need to... You know what? I can do handle effect. So this is the default handler over here. If I have the interpreter scope await update, this is the one that is breaking it. If I do true here, this is just going to lead to infinite loop now, right? Yeah, this is we now have infinite loop, which is why that should not be the case here. Scope await update. This has scope. Maybe it should also take the symbol here. Like, what am I looking for, so that I can log the things. Symbol and scope. Let's do that. Await update. Name and scope. And this over here. Name and scope. And then this over here is going to be name and scope. And I will say over here, want to switch to a language praised for its coroutines. What's the language praised for its coroutines? The Golang. Name. If name is TTT, use a single equal here, then a fact discontinue a exception failure This definition has types stop and error bool. This is general, less general than for all a. Stop and general. What do you mean? I will return the unit here. What do you mean? Hello, Ribbon Main. How does this break my type inference in OCaml? Tell him it's my own language. I didn't say that. What? Is it because effect discontinue? It just has continuation and exception. This should be still. Like, why is that the problem? Yeah, I don't get anything right now. I'm sorry. I don't get what's OCaml is saying to me. AB continuation, AB. Yes. Oh, wait. I need an else here. Okay, there we go. I forgot an else. The error is kind of like really misleading though there. Alright, so we have TTT is not found, the scope is recursive is not closed, so we are using the normal handler here while doing this, while compiling. Wait, it says while compiling? While compiling const, while compiling the module here. Wait a second. For syntax, module. So it happens over here when I'm doing this compilation. I have entered the scope, which also entered the compiler scope, which is a recursive. I am compiling. Since this contains a const, it tries to evaluate it. But it does that inside a fork. I still don't see the issue. Like I just fail to see it. Let's see. We have this is my stack trace. Find, opt, evaluate the type. Right. So the stack trace contains this. This code is literally inside of a fork. And fork is handling the effect. Hello? This is impossible. Like I have a stack trace, and stack trace is saying that I have the effect handler installed. Maybe I don't get something about OCaml effects. Like over here, right? I'm forked. So let's do this. Effect perform. Scope. Await update. Symbol. Create 1, 2, 3 and stay dot scope. Returns a boolean. Ignore it. So let's see if that's going to be handled using this over here. 1, 2, 3, right? That's what I want. And as you can see, this code panics. Wait, the panics is different here. We have unhandled base var await update. Wait, what? Now I have a different error. Is OCaml the language which is RNG? Throwing random errors at me? I'm doing something completely wrong, it seems. Like, this effect was handled before and now it's not handled. What if I just found a bug in the OCaml runtime? There's no way, right? It's a bug in my code. Like, why would... Why would this... Why would me performing an effect here change what effects are handled when we continue, right? Because that makes absolutely no sense. Also, is this even being handled? Because I said 1, 2, 3. So await update. Oh, wait, but now we are actually being handled by this thing, right? By the proper thing, right? Over here, right? If name is 1, 2, 3, then 1, 2, 3 handled by proper handler, right? Let me just print this. 1, 2, 3 was handled by the proper handler. Okay. What if I try to perform the same effect twice? Okay, I think I see the issue. The effects are working completely not like I expect them to. Wait, what? Oh, wait, no, it makes sense. It is handled by the proper handler. So I'm waiting and other things are happening. Okay, no, this actually is making sense. Now, never mind. Because this is handled by the proper handler, I am pausing the execution because I don't continue immediately here. But what if I continue immediately here, like this? False. Okay, and then what if I do true here? Because this should lead to infinite loops. Right? Yes, we have infinite loop now. Oh, it's because 1, 2, 3, right? I think... Okay, if I remove the 1, 2, 3s... Then we have infinite loop again. That makes sense, because there are other recursive scopes. I don't get it. It returned false. It's recursive and not closed. It returned false. Even although the stack trace says that I'm here. Right? Let's look at the stack trace again. This says that I am inside this function over here. I am inside over here. This is inside of a fork. And fork is installing the handler. For this effect. Should override the default one. Let's do it more explicitly here again. Let's do a try. Let's do a try with effect scope await update. Symbol and scope. Let's try implementing this directly here. Even though that should not be necessary. If symbol name is TDT, then TDT handled properly. Please tell me that you can handle things properly. TTT is handled properly. And then I awaited update, and then TTT is found. Wait, what? This makes no sense. So they are saying that this effect handler is working, but the one from this function doesn't? Why so? Because this is going through another function, but does it matter? That makes no sense to me right now. Let's move this over also over here. So what? Okay, can I like re-raise the effect? We just do effect perform. Effect continue K use an effect perform scope await update symbol and scope. Is that what I do? And then we panic because it's not handled by the proper handler. That makes no sense, right? Because all I'm doing is I'm doing a fork. Fork accepts a function. Right? This function is going to be over here. I'm handling like a couple effects here, and a couple effects are handled in this place. What if I... Okay. Let's try copying this here and handling this effect inside of the fork over here. Over here. If I have an effect which is await update from the scope, tell me if this is handled properly over here. It is. Okay. So you're saying that I'm calling the function f like there's literally no difference here. So I can do it here, but I couldn't do it in the other place? I cannot do it here. I can also try scope fork F here inside. Like, technically it's the same thing. Technically this is the same thing, literally. And this handles it properly. Wait, what? That makes no sense. So now I am handling it actually using this effect handler. I want to have like a minimal example or something. Let's have do you have like a playground here or whatever? Let's have a playground. New folder, playground, OCaml playground. Let's do that. We will have new file Dune. Cast bin. It's going to be an executable public name OCaml playground. Name OCaml playground. Libraries. I don't need any libraries here, right? And then we do OCaml playground.ml. So what I'm doing is basically this, right? I say that fork f is so first of all I'm doing type underscore effect d plus equal foo, which is I don't know, let's say unit into unit effect d, for example, right? So when I'm doing fork, I'm just going to try call the function f, and then if we have the effect foo, and then the continuation, I'm just going to say effect deep continue. I'm just having the alias for this. Effect deep continue k using the unit, right? That's literally what I'm doing. And then over here print handled in fork, right? Where's print new line, print end line, do that. Okay, and then we have fork 2, which is literally the same, which is going to be saying handled in fork 2. And then here's our main function, where we just say fork 2 function into fork function effect perform foo, like that, you know. That's what I want. Let's try running this. Oh, where is it? Build default OCaml playground. No such file or directory. Wait, what? Wait, now I'm inside there. Oh, it's because like, okay. OCaml playground. What do we have there? Is it not built? It's supposed to be built, right? Where are the binaries in OCaml? That's also a difficult thing to figure out. Gonna do OCaml run. The Dune run. What does Dune run even do? Is it doing anything? Print And line hello. How do I run this code? Dune exec. Camel playground. Camel playground exe. That's not found. Where is it? Why is it not existing? It's an executable, right? Hello? Where does Dune put executable? Dune place executable is build directory by default. Corresponding to the build context, build default, or build release. Build default. Camel playground. It's not like. Hello? It did not generate the executable. AS 98, 97, 72. Hello, hello, hello. Why am I do not creating the executable? Is it stupid or something? If I have like this thing, like it's trying to compile it, right? Dune build, right? Dune build. Did you build it? Now it's build it. Wait, what? That makes no sense. So Dune build built it, but Dune build watch was not building it? What? That makes no sense. Oh, Camel ecosystem is so weird. I don't know. Is that my issue? Because I have the command. This over here is just running the Dune build watch. So I was like it was already building it, but it didn't create the executable. That makes no sense. Okay, now it did, and now I can run it. Okay. Okay, so yeah, there we go. We are handled in fork. Is it going to rebuild it though? Let's see if it's rebuilding it properly. Hello 2. That's the wrong file. This one. Hello 2. So this is going to be rebuilt. And this is still the old executable. I hate it. I don't get it. I literally have let's close this. Let's see. Let's do it explicitly. Dune build watch, because this is supposed to rebuild the things if they change, right? Now it's hello 2. But if I say hello 3 here, this thing has been rebuilt. Now it's hello 3. Okay, I guess I'm doing something wrong then. What am I doing wrong? Why is the executable.exe? Is because OCaml is just adding the exe as the like it doesn't matter in Linux, but OCaml is doing it anyway. Okay, so it means that technically I'm doing Dune build OCaml index, right? And this thing, watch. Maybe this means that it's not building everything. Okay, maybe. Yeah, I'm building the JavaScript here only, not the executable, right? Can I just make it build everything? I don't know. Fine, it's working right now, is what it matters, right? Okay. So what I'm trying to understand is this. What if I... So right now, it's handled in fork. It's handled with using this exception handler, effect handler, because that's the inner exception handler, which makes sense. So what happens if I don't do this. Let's just do fork is equals to f. Then it's handled in fork 2. That's what I expect it to do. But what if... Well, I mean, technically we have another effect, right? Let's have another effect, which is like foo2. And over here, I'm handling effect foo2. Handled in fork. That's how it's supposed to be. Okay. Why is my program not working like this then? I have some stupid bug, probably. TTT handled properly. Wait, what do I have currently in my code? Is it also because I wasn't rebuilding it properly? I'm lost. Interpreter common. Did he handle properly 3, which is not it. Wait, is it just... Wait, did I just rebuild and it works? Is that what happens here? So this is not needed. Oh, wait, no, it works because I did this. I remember now. Okay, yeah, the difference is that I tried forking inside. But if I try to do scope fork using function this, and then I try to do that by calling the function inside, then this is not going to work, right? Because now it's handled in properly 3. But if I remove this effect handler, then we have a problem. Yes. Okay, so this makes no sense. Can I make this in the playground? Yes. So here, yeah, here's the difference, right? So in fork 2, what we're going to do, we're going to fork function into, and then we try calling the function f like this, right? Wait. Yeah, because fork 2 is supposed to do this for me, right? I'm just doing fork 2, which is a wrapper around fork. And I'm doing the effect that is handled in this function. I want this to be handled. Handled in fork. This works. Okay. Why does this not work for me then? Is this what I'm doing? It is. I don't see the difference. Maybe I'm doing something else. I don't know. Do I have continue with? I'm using continue with, right? Sometimes. But that's for using the standard library. Handle effects. For the source reading. Just functions. The parser. Uh, I literally don't understand it. Do I stop trying to understand it and like just use the version that was working? So the only difference is like where do I place the handler? In one case, the handler is placed properly, and in one case, it's not, which makes zero sense to me. So in the interpreter, instead of doing scope fork, I just remove this altogether, and I will handle this thing directly over here. And if I do that, then the effect is being handled. Otherwise, it's not, which is very weird. There's a scope await update. It is handled properly, right? So now we have the infinite loop though, which is a different issue though, completely. So what is happening is that we were looking for TTT, right? We were looking for TTT, and eventually we actually found it because we awaited the update, right? And then we have infinite loop somewhere else. Okay, let's figure out why do we have infinite loop. This is going to keep being trace. If the binding is not found. So I have waited. In this example, the TTT was waited for, which means that this scope has been closed, right? And then can I say over here something like print evaluating expression at and print expression data span? Like what is happening right now? So I'm evaluating the expression over here. This is the type expression, right? And that's when we have a deadlock or something. That makes sense, which means that I'm doing evaluate the type, right? Evaluate the type though should never deadlock. Or is it? Like there is no awaiting happening in the substitution. Yeah, there is not. Okay, let's print evaluate an expression over here. So I was evaluating this, I was evaluating this, I was evaluating that. Okay. Let's say that I'm done evaluating over here in the end. This is type expression. This is type expression. I'm done evaluating this. Okay. Maybe that's not the problem then. Here's the actual evaluation. We're evaluating expression. Result is this. And then we return results. Let result be this result. And this is going to be done evaluating expression. So the last thing that I was done evaluating is expression this. Wait, what? I also am done evaluating that. I guess it's because like of the async. It's a little weird. Evaluating this, and that is evaluated. Evaluating this is evaluated. Evaluating this is evaluated. But then I was evaluating that expression. 224 to 227. 224 to 227 was never evaluated. And it has a deadlock instead. Why is that? That expression is a binding expression, right? That expression is a binding expression. So let's see. Over here. Looking for binding, print, binding. Let result be this in result. Done looking for the binding. This one, right? 224 to 227. I was looking for TTT. And then I was looking for TTT twice here. Which makes sense. I'm looking for it twice. Both of these lookings were done. But after I am done looking for TTT, that makes no sense. That makes no sense. Like, can you tell me why? If this line has been printed, right? This is like so the match expression basically has finished, right? We're just returning the result here in the end. So the match batch has finished. Okay, substitute bindings is not finished. Okay, maybe so yeah, okay. This deadlocks substituting the bindings. Oh wait, it actually makes sense. Wait, this is an impossible type. That's why it actually makes sense. I wrote an example that makes no sense. That's why we should have a recursive like checks or something, like, because if type T here is the type which is a tuple of T and T, then like basically what happens here, we know that T is a tuple of T and T, right? So this is T and T, and now we want to replace this with T and T, and now we want to replace this with T and T, because that's what the type is, right? And it's just been done infinitely. But that's not what should happen. Because we should not do that. Yeah, we should not do that. How do we not do that? So I was previously having the recurse cache for this reason. That makes sense. So we have this thing that's called substitute bindings, right? But if a typer is recursive, then it's going to do it recursively, basically. If a type is recursive, then it's going to do it recursively. So I need to not look at the same type twice. Right. And to do the same type twice. So can I have something like type recurse hash? That's going to have something. You know, visited things. I'm not sure what it is there, right? But what should happen is that I should not visit the same type twice. Types are inference variables. Inference variables. I should just check them for physical equality. Which means so how do we have something that based on physical equality? I'm gonna have a hash table. Can I have like a polymorphic container that can do like any object in OCaml? There is a hash table. Is there like wrapper physical equality? Like, can I have the physical equality as a value? You know, like the ID or whatever. There is object magic. No, object magic is like the trans. Just changing the type without type checking, right? Wrapper. What is object wrapper? Identity. T, type T. What is object wrapper? Camel obj model. Do your plugins, please. In VS Code. There's a long list. I have 100 plugins installed. What are you interested in? The ones that is that you actually see in action is basically the theme, which is one dark, and the and like the particle effects, which is the power mode, and then the language servers, which is OCaml platform, I guess, is currently being used. Operations are internal representations of values, not for the casual user. Okay. Reachable words. Computes the total size of all heap blocks accessible from the argument. Field, set field. Double field, set double field. There's even no documentation for this. Beautiful. Hey yo, it's my Factorio streamer doing programming. Is this for your full-time job? This is not a job, this is just a hobby, just like Factorio. But I am working as a programmer too. Didn't expect to see a game written in functional programming. The game that I have on Steam is not written in functional programming. That one is written in Rust. Making me feel I should restart using Haskell. What are you currently using? So like, I want something like a hash table. So how do hash tables work? The hash tables are hashed associated tables with in-place modifications. They do the thing. Hash table is only as good as the hash function. The polymorphic hash table is useful in simpler cases or in interactive environments. It is the polymorphic hash table hash function defined in the OCaml runtime, as well as the polymorphic equality. Yes. So hash table hash is just converting this to any... Okay. That makes sense. Just hash is not enough though. Okay, well, I mean, I can just do a hash table for every single thing separately, right? I just wanted to store all of them in the same thing. So recurse cache, we will have, I guess, types, which is types. That I would store in a hash table. Wait, I want it based on the physical equality, right? Not on the polymorphic equality. Is there such a thing? OCaml hash table based on physical equality. To create a hash table, you must use the functional interface hash table make. And equal is physical equal. But then hash, this is still problematic as explained above. Yeah, we're thinking of trying the advent of code in Haskell. What's the OCaml for then if the game is in Rust? Because I'm trying to make my own programming language. That's a different project from the game. I have two projects. One of them is game, and one of them is the programming language. So the programming language is written in OCaml. The game is written in Rust. And I'm thinking of trying to do the advent of code in my own programming language. I'm just implementing recursive types right now. And recursive types have a problem of infinite recursion when I try to traverse the type, right? Because they are recursive, literally. It means that I cannot traverse the type. Even printing the type, right? Like, how do I print a type? Let's think about this. Because when I print what a type is, I will just be printing recursively infinitely, right? So I should print this as recursive. At least, like, for now I only have anonymous types. So this is still an anonymous tuple of itself and itself. Functional OOP lazy imperative, what do you have in mind? The goal of the language? The goal of language is to be the language that I like. It's going to be I don't want to say functional, but we will have functions, I guess. It's not going to be object oriented, not lazy. I guess imperative is the closest thing, but it's going to be I guess maybe like effect oriented programming language. So in Haskell, you encapsulate the side effects using monads. And in this language, you encapsulate the effects using the effect system. There are a bunch of new programming languages that are starting to appear that have these effect systems. This is like a new thing, I guess, relatively. But yeah, like functional languages, when we talk about that, it's, I don't know, like I still don't understand. I stopped understanding at some point what is a functional programming language. Like, what's the definition? Capture effects using effect system. Well, yeah, it's basically we just have the type system that is going to track not just the types of the function arguments and the function results, right? That's what you normally have. Just a function is a thing that takes the argument, returns the result. What we track one more thing, which is what the function can do while it is like going to be evaluated. For example, some functions can throw exceptions, and some functions do not throw exceptions, and we want that information to be present in the type system. Like I said, that is solved in Haskell using monads, but monads are a little more difficult to work with than the effect systems. Look, rock language. Yeah, like rock language. Does rock language has the effects? I don't remember. I did look this a little bit. I didn't really try it much. Mr. Runtime, hello. I don't think this language. Looping effectful functions. Effectful. Side effect. Sometimes you need to repeat effectful functions. No, I think Rock is just like a normal language, kind of like Rust. So it's not storing that information in the like, for example, this, right? This is add number from stdin. This is a function that uses the standard input, which is a side effect, but it's not present in the type system here. So yeah. What I'm doing is closer to languages like Anti or Coca, where if a function can use the console that it's explicitly stated in the type system here. Need Coca stream. While drinking cola. Okay, hold on. This is... I have made progress of this for the recursive types here, but we need to continue. I need to have a recurse cache. So in my Rust version, here's what we had. Mcast, right? If I go here, we literally have this thing that is called recurse cache, right? So a recurse cache just makes it so that we never traverse any data structure with infinite recursion, which is what's happening to me right now. Yeah, so this was working with any type that is identifiable, right? So yeah, I guess I can just add IDs to the variables, and that's going to be easy then. Yeah, just make these things identifiable, which means that they return the ID. That's it. Yeah, makes sense. Like pure script effects. I don't think it's like pure script effects. Pure script is not an effectful language. Pure script is like... Oh, wait, actually, maybe. Like, there are effect libraries for Haskell too, right? But I thought pure script is literally just like Haskell, where you just use the monads. So greet is a function that returns string into string. What's the type of function main? That's the question here. Isn't it still done with monads here? Or is it done with effects? I didn't try this language. I did use in Haskell the library that is called Effectful. I don't know. I don't know if that's any similar to the pure script stuff. Effects library. This is a like introducing the effects using the existing monad system, but we can have the effectful language with effects being created without having monads. Monads is just allowing you to treat your like code as data, which is not necessary when you're actually writing code. PureScript is monad free. So what's the type of this function? Quick start guide. Where's the tutorial? Try PureScript. Can I try it in the browser? Main effect unit. What's effect? What's effect? Is effect any effect? Anything can happen in the main function? That's a weird name for anything can happen. Alright, anyway, I'm trying to prevent the infinite recursion. So, yeah, maybe I do this. Maybe I do that. Substitute bindings. So recurse cache would just be like a hash set. A set. Go to hash table. What's the domain? Web? The domain of what? The programming language that I'm making? The domain for the programming language is going to be everything, including the web. But also other things. I do want to target the web because I want my programs to run in the browser. I want to be able to write the shaders in it, so it's also going to target the GPU and the native applications too. It's just a general purpose programming language. Hash table T from ID into unit, because there is no hash sets on the hash table, so just the value is going to be unit here. So this is going to be visited, right? I probably want the recurse cache to be moved into somewhere. Let me move this into the utility. Recurse cache. Hello? .ml. So we just have something like create is visited is hash table create 0 or something, and then we say visit visit a thing, visit ID, I guess. because there's no traits in this language. And then visited. Then we say hash table add ID unit. And then we have visited add. Okay, and then we have is visited ID. It's going to be visited hash table find opt ID option is some, right? That's like just like a small thing like this. That's all that I need. So now I also need IDs, which means that in the inference, since I have the inference variables, I need to store IDs in my variables. It's not even in the variables, right? It's not in the variables themselves. It should be in the root variable data, like over here. That's what it should be. ID should be stored here, I think. When I say new not inferred, we create a new ID, right? It's a little weird though, because like sometimes when I'm merging two variables to be the same, one of the IDs is going to be lost. But that's fine because it's only going to be used for recurse cache. But maybe it means that I should not call it ID. Maybe let's call it recurse ID. Just so that I don't use it as normal ID. So you can feel the complexity rising. Yeah. The complexity is definitely rising. So I think like my thing actually works right now. I'm just traversing my data structures recursively, and I have recursive types now, which leads to infinite recursion. That's the problem that I currently have. So I need to stop the recursion when I visit the same thing twice, which is what the recurse ID is for. So when I unite the data, a recurse ID, I'm just going to ignore the recurse ID of the second thing that I'm uniting with. So only the first recurse ID now exists, which is totally fine. Okay. And then I will also have, I guess, a function. I'll need to have like a function which retrieves the ID. So we'll have a function ID variable is going to be ID variable is find root variable. That's my data. And then I return data recurse ID. There we go. Usually this means there is a rewrite incoming. Yeah. Well, I mean, the rewrite was happening not because of the complexity, though. That's not why I started the rewrite into OCaml from Rust. The complexity was actually fine, I think. The Rust codebase was better. Actually, it was easier to understand than this current codebase in OCaml, because OCaml is a weird language that I will never stop complaining about. I think like the only reason it's complex is because of the language kind of here. It doesn't have to be this complex. I need to say here val id is a var into id. Okay. The third right is when you understand the problem. The fourth is the one being shipped. Okay, so now what do? Now that I have the recurse cache and I have the IDs of variables, I can do in my substitute bindings. In my substitute bindings, when doing the substitution, I need to give it the recurse cache, right? So I will say something like this. Question mark recurse cache is recurse cache t. Option. And then over here I say that no. Let's do this instead. I don't like it being like this. So like at some point I want to like create the recurse cache, and that's like the public API, and then the internal recursive thing should use the internal things, you know? So I want sub value, for example, to be sub value impl. And then over here we say that sub value is recurse is going to create the recurse cache. Right? So state value is sub value impl, where cache is recurse cache create. Like this. State value. That's what I want. And then sub row is also going to be sub row impl, subtype fn impl, and everything here is just going to be impl. And we have the public facing functions that create the recurse cache. I'm using that Rust has reached the level of popularity where more people have heard of Rust than OCaml. So OCaml is like son of Rust and Haskell, looks similar. Yeah, not really. I would say that OCaml is more like a son of C++ and Haskell. That's more like it, I think. Have I tried F sharp or F star? No. I probably looked at it once. F star language. A proof-oriented programming language. This one, right? Is it different from the Agda or Coq or whatever? I've been on this page before, but I didn't really like try that language. No. You mean son of C++ and OCaml? No, I'm pretty sure that Rust is son of C++ and Haskell, not OCaml. I mean, OCaml also was a big influence for Rust, I guess. But the type system of Rust is closer to Haskell's, I guess, because of traits. instead of modules, like in because like Rust traces Haskell's type classes. That there's no such thing in OCaml. People are being paid to write Rust inside Google and Microsoft. People are being paid to write Rust in a lot of places, I guess. Maybe there will be even Rust jobs at some point. I think Haskell is an improvement, and OCaml in all departments. Well, OCaml people, I heard a lot of OCaml people say that they hate Haskell. I don't know. I don't know. I mean, I can see the reasons to hate Haskell for sure. But so all of these functions take cache as an argument. I dealt with Haskell but never mastered it or did anything serious in it, but it was part of what gave me the aptitude for Rust. Yeah, also for some people it's the other way around. Some people have become interested in Haskell because of the fact that they tried Rust. Because the Rust Rust is like a lot better than Haskell at like when you already know programming. Rust is not that different from the whatever language you used before, you know. But then you realize that there is like this type system, and then you hit the limits of Rust, and then you wonder what's next, and then there's Haskell, and you look into it or something. You mean imperative style? Yeah, I guess imperative style. Cache, subvalue input, cache. Cache. How come there are never any ads on your stream? I have no idea. I don't do anything about it. Maybe it's because you have an ad blocker or something? Or you have a Twitch turbo that you didn't know about? Wait, yeah, you're not sub, no. Impel. Cache. Could I have done this automatically instead of like doing this manually? This is a little annoying. I couldn't have just have renamed it because that would rename the usage of these methods in other files. Maybe I could have renamed them and then looked at the references outside of this file. Actually, yeah, that's something that I could do. But now it's too late. Oh, what's wrong here? Shape, some value, something, something, something. What's wrong here? This definition has type that, but which is less general than that. Cache recurse cache t. Maybe that? No. Why is it less general? Hello? Is less general than for all? A. Because A is this function. Okay, hold on. It's because we need sub value impl using cache here. That's what we want, right? Isn't it? I hate OCaml sometimes. Let's see. If I try to type this manually, we can go to type A and then a row is of type A row, right? This returns A row T. Maybe this should have a cache. What if I do that? This fixes some things. Yeah, I guess that makes sense. Yeah, that actually makes sense. Okay. And then do the type annotation now. Okay, so we have these like internal functions. These functions should have type cache. Like that. Okay. So over here we create. This is not a function, it's going to be applied because create should have argument. There we go. Okay, there we go. So in order to substitute value, we do this. Then substitute type. State type is going to be substitute type impl using cache, which is recurse cache. Create state type, right? Okay, so this kind of works, but then I never actually check, I never look inside the cache right now. So since I only need to do this for types right now, when I'm substituting the types, if this variable has already been seen before, right? Maybe I need like visit to return boolean whether it was visited or not previously, right? Let visited before like first time, I guess, is what I'm going to return. Is visited ID. Like that, right? What's the problem here? The construction unit has type unit, but description is expected of type ID unit. Wait, what? Oh, ID is not of type ID right now? Is visited. ID. No, this is of type ID. Please. ID is visited. This also returns boolean. Boolean needs to be find opt A. Is it because of the no? Visited is a hash table from ID into unit. So I visited, I find opt. Oh, it's because, yeah, hash table has a different API. Find opt ID visited. Find opt visited ID. And same over here when I'm adding, it's adding, and this is the first argument. Because OCaml has inconsistent APIs between different types. Sometimes the thing is the first argument, sometimes it's the last argument. Okay. So basically what I want to do is do if recurse cache visit ID, then we do this, right? But what is the ID here? ID here is going to be inference variable ID of type variable, right? That's what I want. And that goes into cache, right? Visit recurse cache. Oh yeah, and otherwise we just return the type directly. Yeah, that makes sense. There you go. Let's see if this is going to work. Please, work first try. Type check failed. T is not string. At fake to dos. Char is not T. Wait, what? Visit? Oh, visit for the first time is not, by the way. It's because substitution is incorrect. I need to do a not here. That's what I want my API to be. There we go. Okay, this works. This works with recursive types. It's probably not going to work when I do my language server and I try to hover on this. If I say let x of type t to be whatever. Const f is a function that takes x of type t and returns x, for example. This right now has made wait, what? Unexpected end of file. Save. Maybe save without formatting is why. Okay. This works. So I'm pretty sure what's happening here is my language server is right now in the infinite recursion. Situation. Because we cannot print the recursive types yet, we need to have the recurse cache there too. Can I kill it? Kill cast. Okay. So that it doesn't try to restart it anymore. Okay, so what I want is to do it when printing, right? Print type. Over here. I need in printing this also to be done in the same way. Let's have actually this module impl this struct. Maybe this is the fastest way of doing this instead of doing what I did previously. We have module impl where we have these things, and then I say print type is impl dot print type where cache is recurse cache create, you know, like this. So print type over here is going to be cache recurse cache print type shape using cache here, expression shape, this has the cache, let's add it to the types first everywhere. There's a syntax error somewhere. And expected. Did I not have an end? I do have an end here. Line 99. Wait, what is this? What was here before even? Print expression shape. We have a cache. Oh, because it was a function. Now I cannot do function anymore. Yeah. The cache print expression. No, that's fine. That's the only thing that I need to do. Print value using cache and stuff. They add it to the types everywhere. No. Here and here and here. Cache. 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 And here and there. Everywhere cache. Now cache. After cast 1.1 released, cache. Going to sell the language. I don't know how that's going to work. Okay, now we need to add the cache as the arguments everywhere. Cache. Wait! Hold on a second. I just realized that everything that I did here is completely wrong. Control Z. You know what I can do really easily? Because it is a camel. Remove the caches here. I'm going to say that this is the module impl. And it's not going to be module, it's going to be let impl using the cache. There we go. Which is the recurse cache. Wait, no, it's not. I cannot do that. I can do module. How do you do functors? I forget. make. Could do a functor, right? Just say module and then an argument. Yeah. What if we do module impl? Where we have cache of type cache. Can I have this module type cache is sig and file cache is recurse cache t. That's what I can do. So I'll just do here let cache be a cache, right? And then but then I don't call the impl directly here. But I will say that module cache is struct. Can I do a let module? Like I think I can, right? Let module cache is struct cache. And I will say module impl cache dot print type. Is that possible? I'm not sure. Let cache is recurse cache dot create module. Is it impl and this should be in parentheses? The signature for this packaged module could not be inferred. Turn the signature of these things. I don't know. This looks weird and ugly. Actually, let me do the old way. But I don't have it in Control-Z history anymore, do I? Oh no. Okay, all over. From scratch. It's fine. And that wasn't too bad. Print value shape, cache here, cache here, and type shape, cache here. Why don't I have the print assign expression shape? This. Expression has type cache A, B, C, D. What expression was expected of type E, F unit? What? Excuse me? What are you talking about? Why can I not go to the definition? This is unbound. Line 245. This. What? Expected of EF unit. Print this. Print assign expression shape. Cache. That's correct. How do I get the normal? Error message here and not what a camel is telling me. I have cache. Oh, it's because over here I forgot to add the type, that's why. Okay. Print type expression cache. Print expression with spans cache. Print type expression cache. Print type expression cache. Print type expression cache. Cache. Cache here. Cache there. Cache here. And here. And here. And there. Okay. I'm almost there. What's the language name going to be? It's called Cast. I already have a name. I have a small website, which is a little bit outdated, but you can look some stuff there. If you're interested. Okay, I'm just trying to solve the infinite recursion right now with recursive types. So I'm adding a recurse cache everywhere. That's what's happening. You know what? Now that I'm thinking about this, what I'm doing here, this could have been done with an effect. It would not be present in the type system, but I could have just exposed the this public API would provide the effect handler, which would give me the recurse cache basically. It would take a lot smaller amount of time, and the code would not be that ugly, I think. Yep, thank you for the follow. I mean, I can show you a little. I don't want, because I kind of need to end the stream soon, so I just want to finish this thing. Yeah, come back later. I'm going to do the advent of code in this language, in my own language. That's the idea. Here, I'm getting close to being able to do that relatively easily. I will be implementing some things during the advent of code, I guess, but it's going to be mostly just like support of things in the interpreter and not the language itself. Okay, there you go. So now that works. Now I need to expose the actual functions. So print type, for example, is going to be a print type where cache is a recurse cache create, right? Like this. And we have the same functions, print type shape. I need print value. I need print value shape and print expression with spans. I need to print expression with types. I need print expression shape. I need print assign expression shape. I need print assign expression with spans. Okay, print type expression. Print type expression shape. Print pattern with spans. Print pattern shape. Print binding. Though bindings cannot be recursive, I don't think so. Okay, this says that it's compiling. Okay, is it going to actually compile? Is that all that I need? This seems like these things work. Let's go to this, try the language server. Is it not working? Cast compile, guess a number. That works, okay. What's not working then? Can I do output of the cast language server here? What do I do? I do cast examples recursive types. Cast eval. Okay, there you go. That's the problem. We have an infinite loop, right? Because trying to print it still. Oh, it's because I'm not checking it. That's right. Like I added the argument, but I'm not checking. So we need to have print type. Over here, this needs to check for cache, right? So I say that if recurse cache visit inference variable ID of a variable, then we do this, else if cache visit like this. Otherwise, I will, I guess, print recursive or something. Let's do eval. This is going to work, right? There you go. There you go. It's a little bit like I expected a little less recursive things here. Because so T is a type, which is that, which is this, that. That's a little weird. I expected a little less, but it kind of works. It also means that the language server is supposed to work now, right? There you go. It just says recursive immediately. Lol. Let f is xt into x. F has type recursive. Everything is recursive. Wait, what? It's not highlighting the syntax. Because it's right now not recalc. Okay, there is still like the infinite loop happening here. All right. It's close. It's close. I will probably finish this next time though, because I need to end the stream. So that's close. Maybe I'll fix this off stream. Recurse cache. Almost working. Okay, if you don't do the recursive stuff, like here, then the language server should not be this weird, right? Wait, this also is recursive? Wait, what? Int to string is recursive? Something is wrong here. That should not be recursive. Okay, like I said though, I'll figure it out off stream and lurk. Infinite Coder is live. Yeah, I see. All right. Doing the compiler. Gluing the compiler infrastructure. Sure. See you guys next time. Bye.